about the virtual reality in gaming. Right now, we're living in a period which brings something new to the market, which is the virtual reality. Like about 15 years ago, there was the internet. That was the big new thing that came to the market. Then later on, there was the mobile. And right now, the virtual reality is tending to be the next big thing. But virtual reality expands more than just gaming. It goes way beyond that because people are already developing devices for 360 movies, for 360 pictures like Google Maps and so on. So it'll expand way beyond gaming. But that's a good place to start because if you can do something inside a gaming engine or to create something fully interactive like a game, you can develop more or less everything. So let's start by going through the topics we're going to talk about today. First of all, we're going to talk about the VR peripherals, so devices. Then we're going to go through the performance of those said devices, like the Oculus Rift, Morpheus, and so on. Then we'll talk about implementing the movement in your games so that players don't really feel nauseous or anything like that. So we'll talk about comfort using the VR. Later on, we'll switch to level design when it comes to first-person games and the VR technologies. And finally, I'm going to talk about what we've learned developing our own first-person VR game called Plugged. So let's get started. First of all, I don't know if you're familiar with these devices, but on the top left, you can see the Oculus Rift, the most popular one and the most well-known one. Right on the right of the Oculus, you can see the Gear VR, which is the Samsung VR device. And it's going to be a mobile VR device, which is basically just a placeholder for your mobile phone, which you put in and you have a mobile VR device. On the bottom left, you can see the Morpheus, which is the VR for PlayStation 4. And on the bottom right is the newest edition of this family, which is the OS VR, or open source VR. This one came out to the market, actually not to the market, but as a prototype in less than a month ago. So it's the youngest in this family, and it's maybe the most interesting one because it's completely open source, and you can contribute to its development by visiting their website. So what are all of these? Well, they're actually just another monitor or a display for your computer to use, but with addition of gyroscope, which means that it tracks movement of your head, actually the rotation, but some of them can also track the movement in 3D space. So it gives you a feeling of actually being in the game and not watching or playing a game using the monitor, but actually being in it by moving your head around. The only thing that's missing is audio, but you can just use any sort of headphones and you're in the game. So how does it work actually? Well, to understand, you can see in this picture that it actually splits your screen in two screens, one for each eye. But as you can see, there's a slight offset between them. And that's accomplished by actually replicating your camera into two cameras, which capture the screen that is being rendered and then displayed using the Oculus or any other device. But as you can see, it actually renders twice your game, which means that your game is going to perform a little bit worse than it would without using the VR device. And why is that? Well, all geometry, all pictures, all shaders, everything on your screen is rendered twice with a slight offset to give you the illusion of having your eyes a bit displaced so that it actually mimics the human eye. So, as you can see, those things actually impact your game in a way that, as you can see here, your game performance tends to drop as you add more assets to it. But if you plug in a VR device, it drops even more because all these meshes or shaders or shadows or anything else is drawn twice. It doesn't really drop it down by a half, but it does impact it more and more as you add more and more. So let's get to what actually impacts your game and what doesn't. As you can see, things that impact your game the most are scene mesh complexity on the first place. Why is that? Well, how many of you know how, not really how, but how many of you know how polygons or vertexes impact your game? For example, the more you have on your screen, the lesser the FPS will be. So when you're creating a scene for a PC or PS4 or Xbox One, you have to keep your poly count lower than 3 million. And if you plug in the VR device, you're getting that doubled. So your scene has to be as optimized as it gets. Of course, the other big thing that impacts your game when it comes to VR are dynamic meshes or animated characters. Why is that? Well, not only do they need to be rendered as the static mesh, but they also need to be updated every frame so that animation seems like it's flowing, you know. But this also means that it has to be rendered twice, and it needs to be rendered from different angles since your eyes are displaced. So that's the second biggest thing that impacts your performance. The third are dynamic reflections. Not every engine or every game has them, but for example, the Unreal Engine 4 really has a big set of dynamic reflections, and since your eyes are a bit far away from each other, it renders these reflections twice, which means that your performance drops down significantly when it comes to VR. So you can either turn off the reflections and lose the quality of your game appearance, but you will gain a lot when it comes to performance. So the last thing on this list is scene specularity. How many of you knows what specularity in game is? All right, then let me explain this real quick. When you have a sun or any other sort of light source in your scene and some sort of smooth or reflecting surface, it needs to reflect that light. So the more lights you have in your scene, the more specular reflections you'll have. So basically what this means is that if you have multiple lights placed around a static mesh or dynamic mesh, and you have a VR plugged in, it doubles the amounts of meshes displayed and the calculations done for the specularity. So these are the four most significant things when it comes to performance. But there's a bright side to it, because these other things doesn't really impact your game. These other things are shader complexity, which means that if you create something that's really complex when it comes to shading, like water or, I don't know, lava or something that moves, it's a complex shader, but it only needs to be processed with the graphic card once, since it's being kept in the graphic card's memory, and it knows how to display that one shader. And of course, I'm not talking about the reflections or specularity in it. So number two is post-process. Post-processing means that after your whole scene is rendered, there goes an algorithm that alters the whole screen pixel by pixel. But since the screen is split in two, it doesn't really affect anything, so it's still the same process. It just needs to do the same amount of work. So moving on, shadow complexity. As I've said, the difference between having the VR plugged or unplugged is that your eyes are displaced. But the position of shadows doesn't really have to do anything with the position of your eyes. So this doesn't impact your performance. And of course, normal maps. How many of you know what normal maps are? All right, quite a few. So when it comes to normal maps, they serve to mimic the extra complexity of the mesh or the object on the screen without really having any additional geometry, but only using these maps to mimic the light. But as I've said, light and shadows don't really impact your game, so neither do normal maps. But let's move on from this boring part to movement. Have any of you actually tried the Oculus Rift? All right, how many of you have tried the roller coaster? All right, that's at least half. So I guess that at least a half of you that have tried it have experienced the motion sickness that comes along with it. That's because your body is sitting and not moving it at all, but your brain is telling it should feel some G-forces while it doesn't. So this is the main reason why people feel motion sickness when using the Oculus Rift, because they're sitting still and they have the feeling of moving. So the biggest problem with it is actually the motion, the feeling of moving without actually moving your body. So that's the first thing you need to accommodate. For example, if you're trying to implement a movement system in your game, this is the way that most games do that by implementing something like this. What this means is that when you press W or move forward, your character accelerates to a certain point, which is the speed of walking or running, and then stops accelerating and starts decelerating when you release the key. But as you can see, these are all sharp graphs. The best way to reduce the motion sickness is to do something like this. What this means is that not only your speed should gradually move up, but also your acceleration. So it's a bit of a math problem, but when you think of it, it makes sense because the human body doesn't accelerate at once. It starts leaning, then moving the foot forward, and so on. If you do something similar with the Oculus or any other device, you'll reduce the amount of motion sickness. But also bear in mind that you should by no circumstance move the player without him wanting to move. That's exactly what the roller coaster is doing to you. It's making you move without you touching the keyboard or anything else with no input. But as soon as you press a key and start moving, your body, or your mind actually, is expecting to move inside the game, and it reduces the amount of sickness. So let's move on. When it comes to rotation, most FPS games use mouse or arrow keys to look left or right, up or down. When it comes to Oculus or any other device, you're using your mouse just to rotate left or right, and you're using your head to aim up or down. And this is done only because you can't really turn your head 360 degrees back and still have your hand on the keyboard, and it's not really comfortable. So what you have to do is to allow player to use head for aiming for the direction of movement, but to rotate your whole torso, you have to use mouse as an additional key. But this causes the motion sickness as well, because players tend to turn really fast in some situations. And with a lot of testing and some help from the Oculus team, we've discovered that if you use the comfort mode, you'll get best performance when it comes to reducing the motion sickness. What is a comfort mode? Well, if you move your mouse a little, it doesn't do anything. But if you move your mouse enough, it'll rotate your body by 30 degrees in the direction of your mouse movement. It doesn't really seem logical, But your brain is actually more comfortable with having itself moved by discrete amount of degrees instead of continuous movement. The worst thing we managed to do so far while testing the game is to allow players to actually move their torso by moving their head by more than 60 degrees, which means that if you look on one side, your player starts moving. And it really feels like you're really, really drunk. So not really a cool experience, unless you love being drunk, but let's leave it to you. So just use your reason, and if you try something new and you see that you get motion sick playing your own game, imagine how some people that have never seen it before will feel when they sit to play it. All right, so one more thing when it comes to movement, and that's high velocity movement. Our brain, as I've said before, is not really accommodated to moving really fast. So it's not really recommended to do it either with the Oculus, but you can get away with it. How? By gradually accelerating. Have you heard of the Elite Dangerous game? All right, so it's a space simulation game that supports the Oculus Rift. What they have is a hyperspace jump, and it's a situation in which you move, I don't know, a few light years per second or something like that. So imagine your brain trying to comprehend what's going on when it sees stars and everything else moving really fast. It boils, you know. But how they did it is they actually gradually increase your movement speed to a certain point and slow it down so that your brain can actually understand what's going on. But if they did it by simply putting you in that high velocity, you would feel really, really sick. All right, so enough with the movement. Let's just talk about one more thing. When you're having a VR device on your head, you're not really focused on the physical or real world. And it's really hard for you to find your keyboard or any other controller. So bear in mind that if you're creating a game, you have to accommodate player to a certain set of keys, which will then serve as something that won't really change much during the game. As you can see, this is the most common reaction when people first time try the Oculus. So if you absolutely have to try to implement more than a few keys, just follow these few keys on the keyboard. When we first tried to implement the keyboard movement alongside with using objects or putting out your phone unplugged, we did it by implementing the WASD movement alongside with E and F keys. Absolutely everyone who put on the Oculus and was said to open the door by pressing the E button had to lift up the Oculus, search for the E button, and press it. I'm not, of course, talking about hardcore gamers. They don't do that. But most other casual ones do. So since we already use mouse for rotation, we just figured, well, let's just move those controls to the mouse, and people had a lot less problems finding their way around the game. All right. If you really have to implement anything more than just a mouse, keep it simple and keep it close to WASD. Why? Because that's where a player is going to keep his hand all the time. So if you have to implement any other keys, make it Q, E, 1, 2, 3, 4, Z, X, C, because they're close to your hand, and the player doesn't really have to look down on the keyboard, move his hand to press something, and move it back again, because most players won't be able to do that while wearing the VR device. All right? Number 3, if you have more than just WASD, and you have some sort of, I don't know, inventory system or combo system or whatever, just make players used to those keys and to patterns in which they use them. Because once they get to know the commands of the game, they won't have as many problems moving around or interacting with objects or a game at all. And number 4, this actually goes for level design, but also for this one. And that, listen to your testers and the games and the players giving you feedback. Because if one man out of 100 says that controls are really not comfortable, that's all right. But if 5 out of 10 says the same, that's a problem. So you have to rethink what you've done and to re-implement those things. All right. So enough about the technical stuff. Let's move to the level design in VR. This one in particular is actually a screenshot from a game we made a few days ago, just to test out how the Oculus works with big world and open world and everything else. So when I say level design, I'm actually talking more about world design and placing your assets and actors inside the game so that player won't have troubles moving around, interacting with them, or going through some areas. So first thing that you have to keep in mind is the scale, because once you put some VR device, the scale becomes really, really important. Because if you're making a game without using the VR device, and you set up a room, and you look at it from a side, you're telling yourself, yeah, this seems all right. But once you put the VR device, you notice that your table is this high, while your chair is like this. So it really doesn't go well. So once you put it, you really put things in scale, and it's best way to just put the device on and walk through your level to see what's out of scale, what's too small or too big. And many situations like we did, our level designer is sitting with the Oculus and telling us, hey, this lamp doesn't seem all right. And we're like looking at him, telling him, dude, there's no lamp there. But you know how it goes when you have a VR device on. So once you've done that, you have to move on and think about level design step by step. First step you need to do is to place your level using only the modular parts that are really not the final assets, but just the basic ones to really mock up your level. You're just building big chunks of walls, columns, pillars, whatever, just to see how the room feels, and does it really give the feeling you're trying to achieve, which is grandiosity or, I don't know, small space, confined space, or whatever. Because once you have those big elements in place, putting the details on will be a lot easier. So once you've created your basic mock-up for the level, you just have to go and replace one element at a time. And you go around doing that by importing your static meshes into the game and replacing those big chunks of wall or brick or whatever with those assets. So in this part, you'll already have set up the basic components, such as big walls, a roof, but you'll also have many details in your level, such as the ones you see on the screen. But to get really the atmosphere in place, you won't be able to do that just by placing the assets. You have to move on and think about the lights. Lighting and post-process in your level really gives the atmosphere a nice touch, because lighting can really change how the room feels, and post-process can help you darken, lighten, or I don't know, your room. For example, if you're trying to create some spooky atmosphere, you won't use bright lights, you won't be using much color, but you'll simply desaturate the scene, tone it down, and darken it. And once you've created your lights, you have to deal with reflections, with complete post-process effects, with, I don't know, atmospheric fog or something like that. And once all those assets are in place, you get the complete level. Then you can start implementing coding or sound like that. This is actually the process that is being used inside Bethesda, Blizzard, and similar companies because they have to work in layers. First thing that you saw, that basic blocks, is actually called pass number 1. And it's being done before even the designers have completed their artwork. Step number 2 is done by level artists when all the static meshes are created and implemented into the engine. The third part and the last one are doing people who are, well, level designers mostly, because they are really connected to the story and ambience of the game, so they just know what they're trying to achieve. All right, so actually this goes beyond the VR. This goes for game design at all, but when it comes to VR, you simply have to really pay attention to two things, and that's scale and the path that your player is going to take. Why path? Well, this little fella is your biggest enemy when it comes to level design with VR. Do you know what this is? This is the head tracker for the Oculus Rift. It allows you to not only capture your rotation of the head, but also movement in 3D space, which means that if you move around, you'll be able to move your head through walls, through lockers or whatever you have in the room. So you have to plan everything out so that nothing gets in the way of players' head movement, or you have to implement a system that simply or somehow blocks player from entering walls and similar objects. It's not an easy task, but it's something that needs to be done. How does it work, actually? Well, if you imagine your player as a capsule that's only a collider in your scene, and from top-down view, it's this circle with a cross, then your head can move in this other circle, the bigger one, and that allows players to move head through walls, through objects in the scene, and so forth. So you have to think about it when you're creating your level and place some sort of blockers that are lower than player's head to not allow him to go through the walls or anything else in the scene. How it actually looks is something like this. As you can see, this is the wall and the floor, but the player has stepped next to it and just tilted his head a bit to the side, and you get this effect. Not really a nice sight, and you have to think about it. So that's basically the biggest issue when it comes to head tracking and the Oculus Rift, but it's something that really gets level designers working because they have to pay a lot of attention to placing their assets. So how do we know all of this? Well, we've been working on a game called Plugged for the past 3 months, and we've been doing it from day one using the Oculus, so we have some experience with it and the problems it bears. So let's start from the beginning. First of all, when you're creating a VR game, you really need to stay away from texts in the game. And by that, I mean, you see this phone in this scene. It was something that was supposed to get players informed on what's going on in the game. But as soon as player picked it up, they couldn't see what it says because the resolution of the Oculus Rift is still really low and it doesn't really show this text displayed. I mean, not even you can see the text and you're seeing it on a big screen. Imagine how it looks like when you put the VR device on. So avoid texts at all costs, but then how can you communicate with players not with text? Well, you can do it by level design. For example, if you need to tell your player to go somewhere and let's say he has to go through the door. You would just dim the rest of the room, lighten up the door, or place assets so that the only path available is through the door, or you would just use some other techniques that Feng Zhu is actually explaining really well when it comes to level design. All right. Number 2, as I've said, is highlighting objects like that door. For example, if you have a VR device on and your environment is mostly realistic, anything that's out of ordinary will really stand out. For example, as you can see, this cardboard cutout is sitting at a table. That's not really something you see every day. And the rest of the room becomes really unimportant compared to this one, this model in the center of it. So what I'm trying to say is, if you have anything out of ordinary in your scene, you don't even have to highlight it by some outline or some really bright light. The players will just look around and see that it stands out because it doesn't belong there. And that's the best way to draw their attention to that one object. All right. When it comes to GUI, or graphical user interface, that's a tricky part when it comes to Oculus Rift. Why? Because you just can't have your normal GUI standing on the screen with your mouse picking the options, because players have already used mouse to look left or right, but not to point at things. So the best way to do it is to place it in your scene, like we did, and let players aim with their head to use these labels on the graphical user interface. If you have to put it somewhere inside your level, it's still the best option to simply create a 3D object in the space that players can interact with, instead of actually splatting the whole graphical user interface in front of their head. When it comes to Oculus or any other VR, there's one thing that really bothers players, and that's the dark rooms. Why? Well, not because of any psychological effect, but simply because our eyes are used to light and can't really have dark. So looking at a bright screen that's all black, that's really uncomfortable for players. So make sure that your scene is lightened up so that players can see everything that's important to see in it. On the other hand, if you have to use dark rooms, you can use them in your advantage and put some light objects in it, and players will be drawn to them because humans are simply used to be drawn to the light instead of the dark. Except for Jedi or Sith or whatever. Anyway, as I've said, the scale is really important, but you can also use that in your advantage to get players to feel some sort of emotion. For example, this one room here is the boss room in our game. His actual boss, game boss. So when he enters his room, he's as tiny as a mouse, and he feels insignificant, and it really brings this feeling when wearing a VR device, because you feel unnatural being so small in the scene. And using the scale can, in such a way, can really induce all sorts of feelings when it comes to grandiosity or size of the player, because they feel smaller, or if they're bigger, they feel better about themselves. So use scale to your advantage. And the final, but not least, the VR is still a really good selling point, because when you go to any gaming event and you have an Oculus on your table, it still causes that wow effect, because people are drawn to your table and they want to test it out because they still haven't seen enough of it, and they still feel that nobody has really gotten to the maximum of what it has to offer. So it's still a good way to draw attention to what you're doing. So that more or less completes this presentation. So we can move to the questions. All right, who will start? Here we go.
Hi. I just wanted to ask, what do you believe are going to be the first really successful games on Oculus? And if you still see some niches that are not worked on heavily, where game developers could start now?
Okay, so the first question was, what do I believe will be the first most successful titles? Well, there are already a few that are getting traction, like the Talos Principle from they're called Pro Team. Dangerous from, actually I'm not sure who's the developer, but those are the first two games that fully implement the Oculus without any special plugins. I mean, you can basically plug in every other game by using some plugin from the internet, and it actually allows you to render the scene using the Oculus. But as of now, those two games seem to have the most potential, alongside with Star Citizen, that has been developed for the Oculus from the day one. So let's say that those three were my top choices. And the other question, I haven't quite understood.
So I'm part of a studio that is now evaluating what kind of games they could build on VR. And the question is, what are the niches, like what are the types of games that nobody is working on really?
That's $1 million question, so I'm not sure I can answer it, but let's just say that everybody is working on first-person shooter games or any other first-person game using the Oculus. Actually, I've seen one game here at the conference that is not really a first-person game, but a driving simulator from the third person. But as far as I know, the most popular games are shooters, puzzle games, and simulators, like driving simulator or something like that. But I haven't seen enough of, I don't know, strategy games or top-down view games or RPG games. So when it comes to VR, it's really not that important which genre do you choose, because there's not enough of anything at the moment. But that's going to change real soon. So I don't have a right answer for this, but you just have to go to the Oculus store, and they have all sorts of games for free to download, and you can see which ones are doing best. So that might be the best guideline to start planning your project. All right, moving on.
What's your opinion of different input devices? Do you have a favorite, as in gamepad or Wiimote or gloves or whatever?
Different what devices?
Input devices, as
input
in
devices.
something other than a keyboard and a mouse.
Well, for example, we tried out the War Thunder game using the keypad and joystick. And it's really cool because you actually have the feeling of driving that, flying that plane, because you're actually using the exact same controllers. But as of now, my favorite that I've seen is the Omni Virtuix, but it's still in development, so it's not commercially ready, but neither is Oculus. So they might come out at the same time. But I don't know if you know what Omni actually is. It's a device which has a really slippery bottom and a ring that holds so you don't fall over, and it actually tries to mimic your movement of the foot in the game. So actually, when you run in real life, your character runs in the game. hopefully this will make gamers really in good shape in a few years, but let's just hope. So I don't really have a favorite, but that one seems really cool to me. Also, Razer Hydras, those controllers that are movement of hands in 3D space. It goes really well with the Oculus. And there's this new one, I really can't remember its name. Yeah. The Oculus. Yeah, exactly. So what was the name again? STEM. All right. So it's a device that you put on your Oculus, and as long as in front of it actually scans. Okay, I don't know then what it's called, but there's a device that you put on your Oculus, and as long as your hands are in front of it, it actually scans the position of your hands, so you have a real 3D representation of your hands in the game in real time. But I'm really not sure how it's called. Come again? Leap motion, yeah. Or, I don't know. Google knows, so ask Google. All right. Next question.
People with contact lenses know this effect. After a while, they have to put one out, and they see pretty well. Is this maybe an idea to reduce resolution on one side to gain some?
We haven't really dealt with it right now because, as far as I saw, we got a few few different lenses for the Oculus that ships with the device itself. But as I've read on their website, they're trying to create the Oculus so that every person can order different sort of lenses that really suit their eyes. So it shouldn't be a problem, but it's something that they have to deal with. On the software side, you could, I don't know, reduce or increase the resolution, but you can't really do it on just one eye, at least not without some advanced plugin, because as far as I've seen, no engine currently supports it out of the box. But yeah, it's doable. But then again, if you mess with the resolution of the VR device, it really gets blurry, or the anti-aliasing really doesn't work with it, because it stops working with the Oculus once you scale it up to 130% of the resolution. And it really affects your performance because it's already rendered double and you're making it even more expensive.
I just wanted to let you know that the skeletal tracking device you were referring to is called the Nimble VR. I think it's a laser-based system. It's a Kickstarter project. What is your opinion on the Samsung Gear VR, which is using Oculus technology and has a pretty high resolution screen, seeing as it's using the Galaxy Note 4?
Yeah. Well, when it comes to Gear VR, I think it has even more potential than the Oculus, but outside of gaming. Because when it comes to gaming, people have no problems with sitting home and playing games on their PC. But the Gear VR, as far as I've understood, doesn't really rely on an external PC. It renders everything on the phone itself. So your rendering capabilities are really toned down. So you have to think about your games. For example, if you're making a mobile game at the moment without the VR, it already has to be maximally optimized to run as well as possible on the mobile device. But then again, when it comes to VR, you have to do all that, but it renders double. So it's still a problem, but they're working on it, and just give it a year or so, and it's going to be as good as the Oculus. Actually, the resolution is already better if you put in a good mobile phone. But I'm really not sure what to say, because I know of a lot of people that have already contacted us that are working on projects outside of gaming, like, I don't know, VR shopping malls or simulators of any sort. So there's a lot of potential to it, especially because it's going to be mobile, but I simply don't know how well it will perform and how well can gaming engines be ported to another platform. Because I know that Unity and Unreal, well, not CryEngine, can actually port to Android, but you have to scale it down because it's run on virtual machines, so I don't know. But given enough time, it's going to get in a place where the Oculus is right now, so we'll be able to play games. The only problem I see there are the input controls, but who knows? Roller coaster is going to run well, I guess. All right, do we have any more questions?
Yep, one last question, please.
You mentioned Virtuix Omni, and do you really think that it is a solution for the end consumer because it is really big and the setup needs a lot of space? And my second question is things like Google Cardboard, where you use a device you already have as a virtual reality device. Do you see any future in that technology?
All right, when it comes to Omni, I didn't say it was good. It was interesting. I'm not sure how well it performs, or not to mention the scale of the thing, because you have to put it in a complete separate room because you have to have scanners and whatnot. But it's an interesting concept, and it's currently my favorite. But I'm not really sure what the future brings when it comes to input controllers and the VR. And as of for Google Cardboard, well, it's really a good idea, but it's really ambitious because you have to make one thing suit millions of devices, which is actually what the Gear VR is trying to do as well. But they're saying to you that you can use only this, and this type of phone, not all of them. While Google is trying to make it like something that will work with any phone. So yeah, in the future, definitely, you'll be able to buy some device as a socket for your mobile phone to use it as a VR device. But I don't know. I'm guessing that that's the right way to go, but we're still not quite there, so I can't really say any more about it.
Thanks.
All right. Do we have time for more questions? All right. Well, thank you all for your attention, and I hope to see you around in these 2 days. So, thanks.